Let's dig into this project by understanding what DNS and NSlookup are, or at least refreshing for those of you who kind of know already. DNS is the Domain Naming System, a distributed database of Internet lookup information. One of the main purposes of it is to map Internet names like Google.com to an IP address, which is like its number separated by dots, basically like 192.168.1.1. A lot of you have probably seen that IP address. And really, communication between computers on the internet is governed with IP addresses, and DNS does the mapping from the human readable name to the IP address so that your computer can find Google servers or Facebook servers or whatever. DNS also maintains other lookup information in various resource records. The data in DNS is stored, as I just said, in resource records of various types. There's types that map between human readable names, internet names, and IP addresses. There are some that map between the name and what DNS servers they use, and also map between the name and what email servers they use. And the DNS information is stored in what are called DNS servers. These are computers that store the databases, and usually an organization will have several DNS servers of their own, maintaining sort of local copies of this large system. And really, these systems throughout the internet talk to each other and kind of maintain a distributed database. So it's kind of an interconnected database out there. Kind of getting tongue-tied there, as per usual. And yeah, millions of DNS servers throughout the internet maintain this collective database. So yeah, there's a bunch of them out there. And really what we're going to do is we're going to write a little tool in Python to ask questions to particular DNS servers that we decide on. And then what is NSlookup? NSlookup is a command line tool in Windows used to query DNS servers. Basically, it's a command prompt thing, which is the command line is a text-based interface in Windows where you type in commands and you get feedback from your system. And NSlookup is really a way to query, to ask questions to a particular DNS server that you point at. Like, what is the IP address for this host name? You point it at the server, it'll give you a response, or it'll say, I'm down, or there's no server, or whatnot. But it's a way to query a DNS server. I'm actually going to show you NSlookup here real quick before I check out another slide. Here's your Windows command prompt. I'm going to show you a couple of quick runnings of NSlookup. Here I will just query google.com using actually Google server. See, what I got here to begin is the first part. NSlookup is the command. The first part, this is the address that I'm going to get the IP address for. So I'm going to get this turned into an IP address. This last part, this 8.8.8.8, this is the server that I'm going to query against, the server that's going to give me the information. Let's go ahead and run this. And under where it says non-authoritative answer, this is the answer, where I get two IP addresses. I get an IP version 6 address, which is the one at the top, and an IP version 4 address at the bottom. So these are two different kinds of IP addresses, and both of them are going to work to be able to access the google.com server. But that's a little look at how NSlookup works. We're going to make our own version of NSlookup. And why would we make our own version of NSlookup? I'm going to give you some reasons right now. Why would you want to roll your own when you can always, go and use it like I just did? What's the reason for getting under the hood and building your own, you may ask? One reason is to explore as a technologist. You as a programmer, you need to really understand systems and understand networks. If you go in that direction a little bit more, maybe you're curious. You're going to get a basic look inside a more technical look at the transaction between DNS client, which is what you are asking the question, to the DNS server. So yeah, digging in is useful because you get a little beneath the surface to see what's going on down there. Of course, you can create your own customizations. Any tool that you recreate, you can kind of build it in your own image, which is kind of cool. Like, you don't like the way the house across the street looks? When you build your own house, you can build it your own way, create your own customizations. We're going to use the DNS Python module for doing our roll your own NSlookup. And really what you have to do as a programmer when you use modules or libraries and such, you've got to become adept at reading the documentation, understanding it, and then putting it into use. This is going to be a good practice in that. Although you're not going to see me do that in this video, when and if you do this kind of thing on your own, you're going to have to inspect this module, and you're going to gain some quality experience from that, because this is just going to be a common thing you do as a project programmer. You're going to have to investigate the docs and put them to use, like I just said. Always repeating myself, right? Going along with customization, you can maybe simplify the tool. Maybe the NSlookup, it is fairly complex, and maybe to some it's just not user-friendly. Maybe you want to make your version more user-friendly. Of course, you're going to see me do my version, but I just want to kind of spark your interest to maybe do your own version of NSlookup. Yeah, actually roll your own and kind of put your own spin on the thing. That's a cool thing about programming, where you can kind of create your own world. And with that, we're going to now get into the breakdown of how I decided to create or to roll my own NSlookup. Before we dive into looking at the code for my own rolled NSlookup, I'm going to take you on a little breakdown of the basic algorithm I'm going to use here. I'm going to begin it with the idea of I'm going to create an infinite loop for the queries, where you're going to be able to put in a query, get a result, and then once you get that result, it's going to loop back around and ask you again. And you're going to have the option to leave when you want. So until you decide to leave this program, you're going to be locked into a loop. Going to prompt for a DNS server, and it'll check the validity of the DNS server, like, is the DNS server active? And if you enter something invalid or the DNS server is not active, it's going to default to Google's DNS, public DNS server 8.8.8.8. Is that enough 8s there? I think so. We will then prompt for the hosts that you're going to get the DNS record for, obviously an essential piece. Another prompt, going to prompt for the resource record type. This would be the type of record that you're putting into the query, whether it be the A record that maps the host to the IP address, MX record that gets the mail server or mail servers, NS record that gets the DNS servers for this host, and this also does pointer records as well, mapping the IP address to the host, so the reverse lookup. And so once all the prompts are done, we're actually going to do the query. We're going to package it up, hand it off to the DNS server, and get the results. And the queries are going to be handled differently depending on the type of resource record that's being asked for. But whatever, we're going to get the result back, and it's going to print on the screen. And like I said, it's going to loop back around for the user. And a little note here about the exiting of the loop. Of course, no loop is really infinite. No infinite loop is really infinite. It's going to exit the loop if if the lowercase q is entered at any of the prompts. I've got all the prompts set up to where if you enter q at any of the prompts, it's going to exit. So that'll be the mechanism by which you exit the loop. So this is the plan of attack here. And now I'm going to get into the actual code. Stay tuned here. All right, welcome back, my coding ninjas. And now we're going to finally take a look at this damn code for my rolled on NSlookup, as it were. So this is my version. I went over the code flow in the last video. Now you're going to see the actual code here. Let's take a look. Initially, I'm going to import the DNS resolver module for, of course, DNS record resolution. I'm going to import socket because I'm using socket to create. I have a function that is going to test the validity of a DNS server that is entered to make sure that it is actually serving DNS, and I'm going to craft a socket to do so. As I detailed in the last video, this code is governed by an infinite loop. Really, the main part of the code is going to be running an infinite loop where it is going to prompt for the DNS server, prompt for the host that you're going to query about, and prompts for the resource record type. And then you get your result, and it loops back around until you quit, basically. So that's what you see right here on line 51, where I have my while true. And then you got the series of prompts. The first prompt, enter the DNS server and IP address to query, or queue, and this is only going to take an IP address for the DNS server, no host name. And that's why that's shown there, of course. Then I get into a little loop here while not validate IP and DNS server not equal to Q. This is really an input validation loop where I wrote a function called validate IP that is going to ensure that the IP entered for the DNS server is in a valid format. That's in the the dotted decimal with in the form of an IP address. We're going to see it soon, but validates proper IP address, and then DNS server not being equal to Q means like if you haven't quit, basically. So this is a validation loop. Really, it's going to prompt over and over again until you enter a valid IP or you quit. And here we have a conditional that says if the user entered Q, you break, means exit out of the loop, means leave. Q is going to be the quit for all of these prompts. If you want to leave this program, you're going to enter Q at any of the prompts. Once you got the DNS server entered, put up a message that says checking connection to the DNS server, and we have an if not DNS server. This really means if they entered nothing for the DNS server, I'm going to give a message that says no server entered, and I'm going to default to using Google's public DNS. Those 4.8s, that's the IP address of Google's public DNS. So if they don't enter anything, it's going to default to Google DNS. We're going to keep that ball rolling, folks. And here on line 62, we've got an elif, which I'm calling a function here to check the validity of the DNS server. I wrote a function called scanPort that is going to, given the IP address of the DNS server, it's going to create a network socket and send it to that DNS server, checking to see if TCP port 53 is open. That's the port that the DNS is served on. If TCP port 53 is not open, I'm going to assume that it's not a valid DNS server. Most DNS servers have TCP port 53 open, even though DNS is typically served over UDP port 53. Most servers will have TCP 53 open. So if that port is not open, I'm going to assume it's not serving DNS, and we're going to default to Google's public DNS. So basically, if they don't enter anything, or if the server is found not to be valid, I'm going to default to Google's public DNS. Now I'm going to get into the section where I am going to query for the host. Like, what do you want to, or which host do you want to query the DNS server about? Like, bullshit.com or 2600.com. What do you want to be the subject of this DNS query? We create it initially empty first, and then we say, this is a validation loop right here, where while nothing is entered, I'm going to prompt, and I'm going to say, using this server, enter the host that you want to query. If they enter Q, it's going to be a quit, and they're going to leave. And this loop is going to run until they've entered a host, and then I'm going to get down here. And what's happening down here is you're going to enter the resource record type. And typical resource record types are A for host to IP, NS for name server, MX for mail servers. And you're going to enter the resource record type. So like if you entered 2600.com as your host to query, on the next prompt, you're going to enter what kind of record do you want to look up for 2600.com. Enter the record type, and if they don't enter anything, I'm going to make it default to using the A record, because that is the most common type of record to query, like host to IP address. And like it says right here, the variable is going to go in the RR type, or the data is going to go into the RR type variable. And if they don't enter anything, it's going to default to A, like I said. And again, if they enter Q, it's going to quit. I'm going to handle all the resource records differently, the ones that need to be handled differently. Like for instance, right here. If they enter PTR, it's a special kind of record. The PTR, the pointer record, it is a reverse lookup. first, which the pointer record is a IP address to host name lookup. If they enter this resource record type, then I'm going to kind of change the game a little bit, where I need to validate the IP address to make sure it's a valid IP address using the function that I wrote to also verify that the DNS server is valid. I'm going to validate the IP address, and if it's improper, I'm going to say so, and I'm going to, I think, just loop back around. I think it's going to continue if it's not proper. And if it is proper, what I'm going to do is this is a method to query DNS to do a reverse lookup on line 82. So host will be the IP address, and then it's going to do a reverse lookup, and then it's going to put it into this host variable. So there's your pointer lookup. I also have an option for all. If the user enters all, it's going to grab, it's going to grab multiple types of resource records. It's going to grab the A, the NS, the MX, and the quadruple A, the 4A, which is an IP version 6 lookup. And I do this via a function that I wrote up there, and you'll see it soon. This else here, this else is for any other type of record. So any other type of record would be an A, MX, NS, and I guess any others that I can't think of. It's going to create a resolver object, and then it is going to put the name server that was given into the name server's property, and then it's going to call this method which does the resolution. So line 89 is the method that does the resolution, and you're going to get a set of resource records as a result. Then I'm going to loop through the resource records and print them all, whether it's a bunch of A records, MX records, or whatever. And then you have catching of exceptions, where if there's an error, it's going to report that. And yeah, notice I have it in a try catch. It's because, when you query a DNS server, a lot of stuff can result. So I catch a couple of the exceptions here. And there, my friend, is my main loop. Now I'm going to go over the functions that are here as well. Summarize the functions. I've got scan port, which is going to this is going to validate the DNS server. DNS any, it's going to do a multiple DNS record lookup. And then validate IP, this one is going to verify that an IP address is pretty much in the standard form. It's going to throw out a lot of invalid IP addresses. Let us look at scan port, because it's the one on the top. Up here is the setup for creating the socket. What this is going to do is, overall, this function is going to create a network socket connection to the DNS server that the user specifies, and then it's going to attempt to connect to port 53 over TCP. And if it connects, then the server is somewhat validated. If it doesn't connect, then the server is deemed invalid, and then it's going to default to using Google's public DNS. So on line 6 and 7, create the socket setup basically, and then I create a timeout of 1. I don't know if it's 1 second or 1 millisecond. I think it's 1 second. And then basically, if I don't get a response in that second, I assume that I'm not going to get one. Then I do a try and accept where I attempt a connection to port 53 on that DNS server. And if I get it, I return true. Any exception would mean that it didn't connect or there's an issue. So in that case, just going to return false and say it ain't so. The finally is no matter what, I'm going to close the socket. So I want that to happen no matter what. That's the purpose of the finally clause. And that's scan port. It's like a DNS any. This is for if the user enters the word all for the resource record type, it's going to give them A records, quadruple A records, NS records, and MX records. I create a string queries. It's going to hold all of the results actually. So it doesn't actually hold queries, it holds the results. I'm going to loop through the different types, and really for each type, what's happening here is I am querying for that, or creating a connection to the DNS server, querying for that type, and then I am looping through all of the results. For our data and answers, it's going to give me I'm going to loop through and get all the answers, all the responses, and then I'm just going to concatenate them into the queries string. And the two accepts are really for issues, like if there's no answer or a general exception. And that's a DNS any. You're going to get all these record types from that host. Finally, we have validate IP. And as the comment beautifully says on line 36, it's going to validate that an IP address is in dotted decimal form. And so really just a set of basic checks to ensure that the format of an IP address given is pretty much how it's supposed to be. So, first of all, if it's empty, I'm going to return true. And so here with I'm going to get the IP address in. I'm going to split it by dots. And if I've split it by dots and I don't have 4 elements, I'm going to return false because you should have 4 separate sections once you split it by dots. Then I'm going to loop through the elements and verify that they're in range from 0 to 254, because that's the valid range of numbers for each octet of an IP address. And if they're not in that range, I'm going to return false. So I'm going to return false if it's not equal, if the number of elements, really the number of octets is not 4, and I'm going to return false if the number is in the wrong range. Otherwise, I'm going to return true. because it passes those two tests. And that is validate IP. And there is the code, folks, for this one. The next video, I'm going to run this thing, so you're going to see how it actually goes on some real queries, and that'll be fun. So stay tuned for the next one. But with this one, I am out. Welcome back, my code warriors. It is now time to run my, I guess you could say, version of NSlookup. I still don't really have a name for this thing, but I rolled my own version, and here it is. Here in PyCharm, gonna hit that run. And as you see, as I went over, the first thing to enter is the DNS server. And I'm going to run this through some scenarios, and I'll explain each, of course. First thing I'm going to do is actually just not enter a DNS server to show you the functionality here. If I don't enter one, it's going to say no server entered using the server of all 8. As I was saying when I explained the code, if you don't enter a server, it's going to default to Google's DNS server. And let's find that section in the code real quick, just for demonstration. It's right here. See, if not DNS server, no server entered, and it says, you know, all 8s go into that variable. Yeah. So then the next thing, it's the host to query, like what host do you want to get DNS records for? I'll just do Google. I know they got servers out there, right? Google has a presence on the internet. I'll just say that. It's out there. Enter record type. If it's blank, A is going to be assumed, and the A record will map the host name to an IP address. And that's what we're going to do. I'm just going to enter a blank, and it's going to it's going to check the A record by default, or records actually. I hit enter, and it gives me the A record. So here's the IP address. Really, you know, one of a jillion IP addresses for google.com. You know what? Just for the heck of it, I'm gonna do the same query again and see if I get the same IP address. Because, you know, Google's got so many, but it'll probably give me the same one because it's the same server, blah blah blah, and the record will probably be cached. So, and yeah, it's the same one. All right, and you also see the loop around mechanism where the query is complete up here, and then it asks me for DNS server again. So that's the loop around functionality. Let's do a different kind of query here. I'm going to put in a server that I know is legit, putting in the IP address of it. The cool thing about this is you can query any server on the internet, any DNS server on the internet. You can look up lists of DNS servers and put in the IP address here and kind of check the records of said DNS server. So here's a public DNS server. I put in the IP address, hit enter, and see what the program does is it checks the connection to the server as specified in the when I went over the code. It's going to send a TCP connection request to port 53 on that server to verify that it's up and it's serving on port 53. And if so, it's going to go ahead and use that server. So I'm now using this 19546 blah 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 server, and I can hit it with a record, or what the hell does that mean? I can ask it to get records for a certain host. I'm going to use Google again. I'm going to see if this other DNS server has the same IP address or will return the same IP address for google.com. And an A record again. And yeah, no, actually it's slightly different. It's the same subnet, you see, but the host address is different, 174 versus 14. Of course, you know, Google has probably more computers on the internet than any organization, maybe other than Facebook or something. But anyway, whatever. So now we get looped back to the asking for the DNS server again. And I'll use my previous address. See if I can cut and paste previous DNS server address. Going to do a different kind of lookup this time. I'll use a different host as well. I'll do mlb.com, query that one. And record type, I'm going to change the record type. We've done a record query, so that's old hat. I'm going to use my special all query that I guess you could say customly created. I created an all query that's going to pull the A, quadruple A, NS, which is a name server, MX record. It's going to pull all those together. And if I specify all here, it's going to do that. It's like a combination lookup, giving me all of the common resource records for a certain host. And you see I get a bunch of them. It gives me the A record, and there's no quadruple A records found. And the quadruple A records are for IP version 6, so a lot of hosts out there aren't going to have them. Then we have a bunch of name server records. So these are the name servers, or some of the name servers from MajorLeagueBaseball.com. And then we have an MX record, which is a mail exchange. Basically says this organization uses this mail service or this mail server domain. And I've seen through experience at the protection.outlook.com that is Office 365. So if you see a mail exchange with that, I guess you could say top level domain, that's Office 365. So I can just get from this simple query that the information that Major League Baseball uses Office 365 internally for their mail stuff. I guess a hacker could use that information to kind of further probe, but that ain't me. I'm just a researcher and a coder. So that's the all record. And so it loops back around, of course, and I'm going to demonstrate the Q, the quit function, real quick. You just put a Q, and actually at any of the prompts, if you enter Q, the program's going to exit. And there we go. But I'm going right back in and do another query here. I'm going to show you the a couple of more. Let's do a pointer query. The PTR pointer query is going to you're going to give it an IP address, and it'll give you the host associated with that IP address. And because I don't really have many IP addresses handy, I'm going to use an IP address of a name server and see if there's a pointer record associated with that. I'm going to go default and use Google's DNS. Then the host to query. If you're going to do a pointer record here, you need to enter the IP, not the host name, not a domain name. And I'll enter, this is the IP of a DNS server that I know of. I'm going to see if there's a pointer record associated with it. Not every IP address out there has a pointer record. Here I'm going to enter PTR. And we see we have several pointer records for this IP address. And you see DNS there because this is a DNS server, so it resolves to these different host names. So it's got multiple host names. So there's the demo of a pointer record. Let's look at querying an MX record. I'll use Google's DNS. Then I'll look at one of my favorite sites, 2600.com, the Hacker Quarterly. And I'm going to do MX. This will be the mail exchange, which is mail server. And DNS resource record type is unknown. I don't know. It should be there. I'm going to try another MX lookup. It could be a bug in my code. Google's DNS. And let's look for, I don't know, NFL.com and look at their MX. And we see they've got 2 MX records. So the MX record generally works. It could be that 2600 doesn't list their MX, which it's usually a good idea not to make that public. Less information, less hackable, blah, blah, blah. So I think that's about it that I wanted to show. This is the demo of my version, my specialized version of NSlookup for you. Hope you learned something about the DNS and the whole query matrix and all that, and use this information to maybe write your own customized version or further your study in the domain naming system. It's pretty cool stuff how this public database works that is distributed among a bunch of private organizations that all work together to make the internet stick together like glue. But enough from me. It's now time for you to do your exploration. So with that, I